Atomic and molecular masses. After understanding the laws of chemical combination, the most important thing here in this chapter of basic concepts of chemistry is to understand what exactly our atomic and molecular masses are. And from the previous classes, you must be knowing that an atom is made up of three types of particles, which are also called subatomic particles, and it includes your protons, neutrons and electrons. Now, protons are positively charged, we know this. Neutrons are neutral, we also know this. And electrons are negatively charged. Now, these two together are present in the nucleus and they form the atomic mass, whereas the atomic number is always equal to the number of protons, also called Z, and atomic mass is given a symbol A. So, the mass of the atom is mainly due to the protons and the neutrons which are present in the nucleus of an atom, which are together called nucleons. In this, the electron are not having any contribution or almost negligible contribution. The reason is their masses are almost negligible in comparison to the masses of the protons and the neutrons. So, the word atomic mass basically, though it is actually is the mass of the atom, will be actually the sum of the number of the masses of the protons and the neutrons. Now, there are certain terms which are very close to each other and which are very confusing also. So, first let us understand them one by one. So, if we talk about atomic mass, it is the mass of an atom is called its atomic mass, and it is equal to the sum of the masses of protons and neutrons the atom is having in its nucleus. So, whatever the number of protons and the neutrons the atom is having inside the nucleus, their sum is the mass, the sum of their masses is called the atomic mass. Let me give you an idea what exactly this means is, like if we say nitrogen, it has 7 protons and 7 neutrons. So, together it is having mass 14. Now, remember this atomic mass term is often confused with another term called mass number. See, mass number is only a number and it is the sum of the number of protons and neutrons present in the nucleus of an atom. It is just the number, sum of the numbers of these protons and the neutrons. So, it is the number, whereas like I have told you the nitrogen is having 7 protons and 7 neutrons, so their number is 12, so 14. So the total number of nucleons in the nucleus of nitrogen are 14, which is also called mass number. But its atomic mass is also 14. What does it mean? The reason is why we are having very similar terms, and that the answers are also same 14, 14. The reason is the atomic mass is expressed in terms of AMU, which is also called U or unified mass, and the mass of one proton is also 1 AMU or 1 unified mass. Mass of neutron is also 1 AMU or 1 unified mass. So their sum will be, their masses will be also, like say this will be 7U, this will be 7U, so the total will also be 14U. That is why atomic mass of nitrogen is 14U, and we also call it mass number because that is indicating the number of protons and the neutrons present in it. Since the masses of the protons and neutrons are 1U or 1 atomic mass units, we all often get the same answers in both these terms. Atomic mass. After understanding what is exactly the atomic mass and mass number is, and how we often get confused between these two terms, because mass number is just the number of the sum of the protons and the neutrons present in the nucleons, and atomic mass is the sum of the masses of the protons and the neutrons present inside the nucleus of an atom. We must now go to the unit of the atomic mass. See, the unit of atomic mass, earlier we used to call it atomic mass unit, also called AMU. It is now called unified mass, and its symbol is U, small u. Now what is this? How we define atomic mass unit or U? Remember, one unified mass or one atomic mass unit, 1U is exactly equal to 1/12 of the mass of one C12 atom. That means whatever is the mass of the one carbon 12 atom, 1/12 of that mass is called one unified mass. In some cases, it is also defined in terms of hydrogen. In terms of hydrogen, your 1 AMU which is also called 1U is also called, it is exactly equal to the mass of one hydrogen atom. So, see, this is very important thing to understand. Usually we express the mass in terms of grams or kilograms, which is basically used to define the masses or give the masses of macroscopic particles which are visible to us, which we can normally see around us, and whose masses can be determined by the use of physical balance. But how to give the masses of the subatomic particles or the particles which are constituting the atoms? In science, we give this to define the masses of these subatomic or very small particles which constitutes atom. We gave the term called 1MU or 1U. I'm repeating again. To give or to indicate the masses of the subatomic particles which constitutes atom, we gave a term called 1AMU or U, which is defined in two ways. It is either called, it is exactly equal to the mass of the one hydrogen atom, or it is called exactly equal to the 1/12 of the mass of one carbon atom. Why we have taken carbon and 12? The reason is carbon, the most abundant substance we have, element we have around us. It is one of the most stable elements we have. And C12 means we are particularly talking about its isotope C12, which is the most common and most stable one. So 1/12 of that isotope's mass is called 1MU, AMU or 1U, unified mass. So now you know what is unified mass or 1 AMU is. Now you also need to know exactly in terms of grams, it is how much? Exactly in terms of grams, it is how much? 1 U in terms of grams is 1.67 into 10 to the power minus 24 grams. So you can now imagine how small this is. It can also be written in terms of kg. It is 1.67 into 10 to the power minus 27 kilogram, which is again is a very, very small number. So usually, to make it more convenient for us to remember that the masses, we are expressing them in terms of U or unified mass, and exactly when we will be doing calculations, we will be converting these U's into the grams, and the conversion factor is that 1 U is equal to 1.67 10 to the power minus 24 grams. So after making it, what is exactly your atomic mass is and what is one mass number is, you must understand that if we say like hydrogen, we know that its atomic mass, I will be indicating here atomic masses. So its atomic mass will be how much? We will know that it's 1 U, it will be U, remember. If we say helium, we know it is 4 U. We know that if we say carbon, we know it is 12 U. For nitrogen, it is 14 U. For oxygen, it is 16 U. Like in this case of Fe, it is 56 U. So in this way, we have actually know the masses of all these elements which are existing in the nature.